March 17, 1944. Pratt Army Airfield, Kansas. A $600 or $1,000 B-29 Superfortress explodes into flames on the runway. Not from enemy fire, from its own engines. Within 90 seconds, the aluminum giant becomes a crematorium for 4 crew members trapped inside. By week's end, 3 more bombers will burn. By month's end, 18. The United States is incinerating its own air force faster than Japan ever could. And the man who'll stop it isn't an engineer. He's a plumber who barely finished 7th grade. Captain James Harrell saw the temperature gauge spike first. Engine number 3, 547 degrees, then 562. Then the needle slammed past 580 and the red light started screaming. Fire engine 3! His co-pilot hit the shutoff. Nothing happened. It's not responding. Harrell looked out his window. Orange flames were already eating through the cowling, spreading toward the wing fuel tanks. They were still on the ground, still taxiing, and his aircraft was burning. Everybody out. Now! He yanked the canopy release. The co-pilot was already moving. Behind them through the bulkhead, someone was screaming. The flight engineer. Trapped. Harrell tried to go back. The heat hit him like a wall. Black smoke filled the fuselage. He couldn't see, couldn't breathe. Hands grabbed him from behind, ground crew dragging him away from the plane. There's still men inside. Too late, get back. The wing tank exploded. The blast knocked Harrell to the concrete. When he looked up, his B-29 was gone. Just fire. Just metal melting into the Kansas dirt. 2 men dead. $600 or $1,000 gone. And this was the 17th bomber to burn in 6 weeks. Antonio Validor was watching from Hangar 6 when it happened. He didn't run toward the fire. The ground crew had it. He just stood there, hands shaking, watching the smoke rise into the clear morning sky. Another one, someone muttered beside him. Tony didn't respond. He was thinking about his son, Michael, 22 years old, B-29 crew, somewhere in the Pacific flying one of these death traps every other day. The last letter had come 3 weeks ago. Don't worry, Pop. The engine problems are exaggerated. We're fine. Exaggerated. Tony looked at the burning wreckage and thought, my son is going to die in one of these. Validor, Sergeant Paul Dietrich, was walking toward him. Clipboard in hand, face red. You got engine 3 on 426261 to inspect. Post-flight checklist. Move it. That one caught fire yesterday. Which is why you're inspecting it. See if we can salvage anything before we scrap it. Tony grabbed his toolbox and headed to the flight line. Engine 3. Always engine 3 or 4. The outboard engines. The ones that cooked themselves to death, while the inboard engines ran fine. He'd been working on B-29s for 4 months now. 4 months of watching mechanics pull engines apart, replace cylinder heads, modify cowlings, try new baffle designs. Nothing worked. The rear cylinders always ran hot, always failed, always burned, and nobody knew why. Well, the engineers knew why. They'd explained it in meetings Tony wasn't invited to, using words like aerodynamic flow patterns and thermal conductivity coefficients. Tony had heard about it secondhand from Dietrich, who'd heard it from a Boeing inspector, who'd heard it from some MIT graduate who probably couldn't change his own oil. The explanation was simple: air flowed over the front cylinders fine, but the rear cylinders, the ones hidden behind the front row, they were in a dead zone. No airflow, no cooling. They overheated, seized, caught fire. So fix it, Haniengo, Tony had said. Can't, Dietrich had replied. The engine's designed wrong. We'd have to redesign the whole thing. New cowling, new baffles, new cylinder arrangement. That's 2 years of retooling. We don't have 2 years. So what do? We keep burning planes and hope we figure something out before Japan wins. Tony opened the cowling on engine 3 of 426261. The damage was obvious. The rear cylinders were black, cracked. The aluminum had actually melted in places. The front cylinders looked almost new. He stood there for a long time, just looking. Then he climbed up onto the engine mount and stuck his head into the cowling, trying to see what the air saw. Where did it go? The cowling opened at the front. Air rushed in, hit the cylinders, and then... What? What the hell are you doing? Tony pulled his head out. A man in a clean uniform was standing below, not a mechanic's coveralls, but an officer's jacket. Lieutenant's bars, young, maybe 25. Inspecting the engine, sir. With your head inside the cowling. Trying to see where the air goes. The lieutenant frowned. The air goes around the cylinders. That's what cowlings do. Does it, though? Excuse me. Tony climbed down. If the air goes around the cylinders, why are the back ones burning up? Because the design is flawed. We know that. Everyone knows that. Boeing's working on modifications. What kind of modification, new baffle configuration, should redirect some of the front airflow toward the rear cylinders? How long? 6 months, maybe 8. Tony looked at the burned engine. How many planes are going to burn in 8 months? The lieutenant's jaw tightened. I don't have an answer for that. Then maybe somebody should try something else. Like what? I don't know yet. Tony picked up his toolbox. But standing around waiting for Boeing to save us doesn't seem like a great plan. The lieutenant stared at him. What's your name, mechanic? Validor, Tony Validor. Well, Validor, unless you've got an engineering degree I don't know about, I suggest you stick to following the maintenance protocols and let the people with actual expertise handle the design problems. Tony nodded slowly. Yes, sir. The lieutenant walked away. Dietrich appeared from behind the wing. You got a death wish, that's Lieutenant Morrison, Boeing liaison. He reports directly to General Arnold's office. He seems nice. He can have you court-martialed for unauthorized modifications. I didn't modify anything. Not yet. Dietrich lit a cigarette. But I know that look. You're thinking about something stupid. Tony turned back to the engine. You ever work on building heating systems? What? Before the war, you ever fix boilers, radiators? No? Why? I did. 15 years. Cleveland municipal buildings mostly. Big old buildings with terrible heating. You know what the problem always was? Tony. The steam would take the easy path. Ground floor radiators would be burning hot. Top floor would be freezing because the steam didn't want to climb. It wanted to go sideways. Easiest path. That's fascinating. What's your point? My point is you can't ask steam to go upstairs. You have to make it. You put in a bypass valve. You force some of the flow to take the hard path, and then everything works. Dietrich stared at him. You think this engine is like a boiler? I think this engine has the same problem every boiler has. To heat the air, it's taking the easy path, front cylinders, but the back cylinders need it more, so you gotta force it. Force it how? Add a pipe. Dietrich laughed, then stopped laughing. Wait, you're serious? Why not? Why not Jesus Tony? Because this is a $600,000 airplane with engines designed by Wright Aeronautical, manufactured to military specifications, tested by Boeing engineers, and you want to just add a pipe, a duct, an air duct. It's insane. So's burning 18 planes a month. Dietrich took a long drag on his cigarette, looked at the engine, looked at Tony. Even if you're right, which you're not, you can't just modify a military aircraft. That's court-martial territory. What if I don't modify the aircraft? What if I just test a theory on a scrap engine? We don't have scrap engines. Every engine is accounted for. We've got burned ones, like this one, already written off. Nobody's going to miss it if I experiment a little. Tony, my son's in the Pacific, Dietrich, flying one of these. Every letter I get, I think it's going to be the last one, and I'm supposed to stand here and wait 6 months for Boeing to figure out what I already know. Dietrich didn't say anything for a long time. Then you've got 2 weeks of night shift. Nobody checks on night shift too close. You want to try something that's on you, but if Morrison finds out, if anyone finds out, I don't know anything about it. Clear? Clear. And Tony, if you blow up this hangar, I'm going to kill you myself. Petzontance. That night, Tony started building the duct. He'd sketched it out during dinner, a rough measurements, approximate curve entry and exit points. Nothing fancy. Just a tube that would capture some of the incoming air at the front of the cowling and redirect it around the front cylinder row, dumping it directly onto the rear cylinders. The problem was finding material. He couldn't requisition aluminum tubing without explaining what it was for, and he definitely couldn't explain what it was for, so he went scavenging. Behind Hangar 3, there was a pile of damaged cowling panel stuff that had been torn up in the fires, warped, cracked, unsalvageable. Tony found a section of curved aluminum about the right size. Grabbed a cutting torch and got to work. What are you making? Tony looked up. Another mechanic, younger guy, maybe 20, was watching him from the doorway. Ductwork. For what? Something stupid. The kid laughed. Can I help? You know how to use a torch. 3 years at Ford before I enlisted. Tony tossed him a pair of gloves. Cut me 2 sections 3 inches wide following the curve. Clean edges, no burrs. They worked in silence for an hour. The kid was good. Steady hands. Didn't ask questions. When they finished the first prototype, the kid held it up to the light. This for the engine cooling problem. Maybe. The engineers said it can't be fixed. The engineers aren't here at midnight cutting up scrap metal. The kid grinned. Fair point. You think it'll work? I think it won't work any worse than what we've got now. That's not exactly confidence-inspiring. Tony picked up the duct. It was rough, uneven, the welds were ugly, but the shape was right, the curve was right, the opening was positioned exactly where he needed it. In Cleveland, Tony said, I fixed a heating system in City Hall. 40-year-old boiler, 300 radiators, half of them didn't work. Building engineer wanted to replace the whole thing. Cost estimate $80,000. What did you do? Hi. Added 4 bypass valves and 20 feet of pipe. Cost $47. Worked perfect. The kid whistled. And the building engineer tried to fire me, said I made him look stupid. Did you? Tony shrugged. I made the radiators work. That was my job. He carried the duct back to engine 3. The engine was still mounted on the test stand, damaged but functional enough for a short run. If the duct worked, the temperature gauges would show it immediately. If it didn't work, well, at least he'd tried. He spent the next 3 hours fitting the duct into the cowling. It had to curve around the front cylinder heads without blocking any of the existing airflow paths. It had to seal tight, any leaks would defeat the purpose. And it had to be positioned so the exhaust air hit the rear cylinders at the right angle. It was 300 a.m. when he finally tightened the last bolt. The kid, his name was Eddie Tony, had learned was sitting on a toolbox half asleep. You done? Yeah. You gonna test it? Tony looked at the engine, looked at the duct. This was the moment. If he started the engine without authorization, without supervision, without safety protocols, and something went wrong, he'd be done. Court-martialed. Dishonorably discharged. Maybe prison. But if he didn't test it, 18 more planes would burn next month. And Michael would keep flying a death trap. And 2 years from now, some Boeing engineer would probably invent the exact same thing Tony had just built and get a promotion for it. Fire it up, Tony said. Eddie's eyes went wide. You serious? You got somewhere else to be. No, but then start the engine. Eddie scrambled to the controls, hit the ignition. The engine coughed, sputtered, then roared to life. Tony watched the temperature gauges. Front cylinders 380 degrees. Rising. Rear cylinders 390 degrees. Rising. 410, 430, 450. This was normal. This was how it always went. The rear cylinders would hit 520, then 550, then warning lights, then fire. But at 460 degrees, something changed. The rear cylinder temperature stopped rising, held at 465, then dropped. 460, 455, 445. Holy shit, Eddie whispered. It's working. Tony couldn't speak. He just watched the gauges. The front cylinders had leveled off at 425 degrees. The rear cylinders were dropping toward the same temperature, evening out, cooling evenly for the first time. They ran the engine for 10 minutes. The temperatures stayed flat. No spikes. No hot spots. No warning lights. When they finally shut it down, Eddie turned to Tony, eyes shining. You did it. You actually did it. Tony sat down on the concrete floor. His hands were shaking. Not from fear. From the realization that he'd just solved a problem that had killed 17 planes and dozens of men, with a piece of scrap aluminum and a cutting torch. We need to tell someone, Eddie said. Tell them that I modified a military engine without authorization. You fixed it. That's not how the Army sees it. Then how do we... The hangar door opened. Footlights flooded in. Someone was coming. Tony stood up fast. If it was Morrison, if it was any officer, he was done. But it was Dietrich. He walked over, looked at the engine, looked at the duct, looked at the temperature logs Eddie had been keeping. You ran it, Dietrich said flatly. Yeah? Without authorization. Yeah. And... Tony handed him the temperature chart. Dietrich studied it. His expression didn't change. Then he said, You just saved the B-29 program. Or got court-martialed. Probably both. Dietrich folded the chart. I'm taking this to Morrison. Tomorrow morning? He's going to want to see the engine running. He's going to want explanations. And he's going to want to know why a plumber from Cleveland solved a problem that MIT couldn't. What do I tell him? The truth. You saw something everyone else missed, and you fixed it. Tony nodded. What happens next? Dietrich smiled, grim, tired, but real. Next, we find out if the Army cares more about following rules or winning wars. He walked toward the hangar door, then stopped. Turned back. Your son, Michael, he's based at Saipan, right? Yeah. If this works, if they put your duct on every B-29, you just saved his life. You know that, right? Tony didn't trust himself to speak. He just nodded. When Dietrich left, Eddie turned to Tony. What now? Tony looked at the engine, at the crude aluminum duct, at the temperature gauges showing numbers that shouldn't be possible. Now, Tony said quietly, we wait to see if they court-martial me or give me a medal. Which one you think it'll be? Tony picked up his toolbox. In my experience, both. Tony didn't sleep that night. He sat in the barracks staring at the ceiling, waiting for the MPs to come arrest him. They never came. Instead, at 0600 hours, Dietrich showed up at his bunk. Morrison wants to see the engine now. Tony's stomach dropped. He knows... I showed him the temperature logs an hour ago. He thinks I'm lying. Says the numbers are impossible. They're not impossible. We ran it for 10 minutes. I know that. You know that. But Morrison's bringing 3 Boeing engineers with him, and if you can't make that engine do exactly what you did last night, we're both screwed. They walked to Hangar 6 in silence. The sun was just coming up over the Kansas plains, turning the sky orange. It should have been beautiful. Tony barely noticed. The hangar was already full. Morrison was there along with 3 men in civilian clothes, the Boeing engineers. They all had clipboards. They all looked skeptical. This is Validor, das? Morrison asked Dietrich. Yes, sir. Morrison turned to Tony. Sergeant Dietrich tells me you've solved the B-29 cooling problem with a piece of scrap metal. I don't know if I solved it, sir. I just... Show me. Tony led them to Engine 3. The duct was still installed exactly as he'd left it. One of the Boeing engineers, older guy, gray hair, expensive glasses, walked around the engine twice, then laughed. This is a joke, right? No, sir, Tony said. You put a tube into the cowling. A tube. And you think that's going to redirect airflow in a meaningful way. It already did, sir. Last night we ran this engine for 10 minutes. Rear cylinder temperature dropped to 445 degrees. The engineer looked at Morrison. Lieutenant, this is absurd. The thermodynamics alone... Then prove him wrong, Morrison interrupted. Start the engine. The engineer's face went red. I don't need to waste time proving that a plumber's pipe dream doesn't work. Start the engine. For a long moment, nobody moved. Then one of the younger Boeing engineers, skinny kid, couldn't have been older than 25, said quietly, I'll do it. He walked to the control panel, hit the ignition. The engine roared to life. Tony watched the temperature gauges. So did everyone else. The hangar went completely silent except for the engine. Front cylinders 395 degrees. Climbing. Rear cylinders 405 degrees. Climbing. 420. 435. 450. The older engineer smiled. See, it's following the same pattern. The rear cylinders are overheating. The rear cylinder temperature stopped at 455 degrees, held, then dropped. 450, 445, 438. The smile disappeared from the engineer's face. They ran the engine for 15 minutes. The temperature stayed locked at 425 degrees, front 430 degrees rear, a 5-degree differential, within normal operating parameters. When they finally shut it down, Morrison turned to the older engineer. Still think it's absurd? The engineer didn't answer. He was staring at the temperature logs like they'd personally insulted him. The younger engineer, the one who'd started the engine, walked over to Tony. How did you know this would work? I didn't know. I guessed. Based on what 15 years fixing boilers. The kid laughed, not mocking, but genuine. That's the most beautiful thing I've ever heard. He stuck out his hand. Robert Marsh, MIT class of 41. And you just taught me more about fluid dynamics than 3 years of school. Tony shook his hand. Tony Validor, Cleveland Municipal Buildings class of never finished 8th grade. Morrison was talking in low voices with the older engineer. Tony couldn't hear what they were saying, but he could see the engineer's face getting redder and redder. Finally, Morrison walked over. Validor, you're coming with me. Dietrich, prepare a full technical report on this modification. I want specifications, materials list, installation time, everything. On my desk by 1400 hours. Yes, sir. Where are you taking Validor? Right field. He's going to explain this to General Curtis LeMay. Tony felt the floor drop out from under him. General LeMay. He's in charge of the entire B-29 program. If anyone can authorize immediate production implementation, it's him. Morrison looked at Tony. You better hope your pipe works as well on his desk as it does in this hangar. They flew to Wright Field that afternoon, Tony's first time in an airplane. He spent the entire flight gripping his seat, trying not to throw up, while Morrison reviewed technical documents and ignored him. Wright Field was chaos. Dozens of B-29s in various stages of assembly, hundreds of personnel running between hangars, and Inica's officers shouting orders. Morrison led Tony through the administrative building to a conference room where 5 men were already waiting. General Curtis LeMay sat at the head of the table. He was younger than Tony expected, only 37, but his face looked older, tired, like he hadn't slept in weeks. "You're the plumber," LeMay said. It wasn't a question. "Yes, sir." "Sit down." Tony sat. LeMay pushed a piece of paper across the table. "This is Sergeant Dietrich's report. Says you reduced rear cylinder operating temperature by 95 degrees using a bypass air duct made from scrap cowling material. Installation time 4 hours, material cost 0. Is that accurate?" "Yes, sir." "Why didn't any of my engineers think of this?" The room went silent. Tony could feel everyone staring at him. This was the moment. Say the wrong thing, insult the wrong person, and this was over. "I think they were trying too hard, sir." LeMay's eyebrow went up. "Explain?" "The engineers, they know all the rules. They know how air is supposed to flow, how engines are supposed to cool. So when something doesn't work, they try to fix it inside the rules. New baffles, new cowling designs, new cylinder configurations. All complicated, all expensive, all slow." "And you?" "I don't know the rules, sir. I just know that when something's too hot, you move the cold air to it. Doesn't matter if it's a boiler or an airplane. Cold air goes where it's easy. You want it somewhere else, you make a path." One of the other officers, a colonel with right aeronautical patches, leaned forward. "General, with respect, we can't base a military procurement decision on the intuition of a maintenance mechanic. We need proper engineering analysis, wind tunnel testing, thermal modeling." "How long?" LeMay interrupted. "I'm sorry. How long for your proper engineering analysis?" The colonel hesitated. 6 months, maybe 8. "We lose how many planes in 8 months at current failure rates?" Nobody answered. LeMay turned to Morrison. "You saw this engine run?" "Yes, sir. 15 minutes. Temperature stable, no anomalies." "And the installation, how complicated?" 4 hours, standard tools. Any competent mechanic could do it." LeMay looked at Tony again. "Can it be mass-produced?" "The duct, yes, sir. It's just aluminum tubing, bent to shape. Any shop with a pipe bender could make 100 a day. And installed on existing aircraft, not just new production." "Yes, sir. You'd have to pull the cowling, but the engine doesn't need modification. Just bolt the duct in place." LeMay stood up. Everyone else stood too. "Colonel Henderson, you have 72 hours to produce 50 prototype ducts to Validor specifications. Morrison, you'll oversee installation on 10 aircraft, 5 new production, 5 existing operational birds. We'll run them for a week. If the temperature reduction holds, we go into full production immediately." The colonel from Wright Aeronautical was shaking his head. "General, this is highly irregular. We're bypassing every safety protocol." "Colonel, we've burned 42 B-29s in the last 3 months, killed 67 crew members on American soil. Not one enemy bullet fired. You want to tell me about safety protocols?" "Sir, I'm simply saying that we need proper vetting." "What we need," LeMay said, his voice dropping to something quiet and dangerous, "is for these aircraft to stop catching fire. If a plumber from Cleveland can do that with scrap metal and 4 hours of work, then God help us, we're going to let him. Dismissed." Everyone filed out except LeMay, Morrison, and Tony. LeMay walked to the window. Outside, a B-29 was taxiing for takeoff. "You know what these aircraft cost, Validor?" "Yes, sir. $639,000. "Wrong. They cost lives. Every time one of these burns, we lose 4, 5, sometimes 8 men. Good men. Trained men. Men who've spent a year learning how to fly, how to navigate, how to drop bombs on targets 8,000 miles away, and we're killing them with faulty engineering." He turned around. "Your son flies B-29s." It wasn't a question. Tony realized LeMay had already read his file. "Yes, sir. 499th Bombardment Group, Saipan." "If your duct works, if we can get it installed on every operational aircraft, you'll save his life. You understand that?" "I hope so, sir." "You better do more than hope, because if this fails, if I put my weight behind this and it turns out to be a plumber's fantasy, I'll be grounding the entire B-29 fleet, and the war in the Pacific will stall for 6 months while we figure out what the hell to do. That's 1 million American casualties, maybe more." LeMay walked closer. "So I'm going to ask you one more time. Will this work?" Tony thought about Engine 3 running smooth and cool in Hangar 6. He thought about the temperature gauges holding steady. He thought about Michael somewhere over the Pacific Ocean, flying a plane that might burn at any moment. Yes, sir, it'll work. LeMay nodded. Then get out of here and pray you're right. The next week was the longest of Tony's life. They installed his duct on 10 aircraft. 5 new birds just off the production line at the Boeing plant in Wichita. 5 operational planes pulled from training squadrons at Pratt. Each installation took between 3 and 5 hours, depending on the crew. Some of the mechanics worked in silence. Others asked Tony questions: why this angle, why this diameter, why this position. He answered as best he could, but the truth was most of it was instinct. He'd looked at the engine and seen where the air needed to go, that was all. On the 4th day, one of the test aircraft, a new production bird tail, number 426365, had an engine fire during a training flight. Tony was in the maintenance hangar when he heard. His heart stopped. Was it the duct? He asked Dietrich. Did the duct fail? Don't know yet. Plane's on the ground. Crew's safe. Morrison's investigating. An hour later, Morrison came back. His face was grim. Engine 2 caught fire, he said. Not Engine 3. Tony felt the air return to his lungs. Engine 2 didn't have the duct. Exactly. Engine 3, the one with your modification, ran at 420 degrees the whole flight. Engine 2 hit 570 and seized. Standard failure pattern. Morrison allowed himself a small smile. Your duct works Validor. By day 7, the results were undeniable. 10 aircraft, 40 engines total. 16 engines equipped with Tony's bypass duct. 24 without. The modified engine, 0 failures. Average operating temperature, 425 degrees. Temperature differential front to rear, 5 degrees. The unmodified engines, 3 failures. 2 fires, 1 forced landing. The data didn't lie. On April 28, 1944, General Curtis LeMay authorized full-scale production of what the engineers were now officially calling the Validor Bypass Cooling System. Boeing's Wichita plant retooled immediately. Wright Aeronautical began producing ducts by the hundreds. Every B-29 coming off the production line would have them installed. Every operational aircraft in the fleet would be retrofitted within 90 days. Tony received written orders to report to the Boeing plant in Wichita to supervise initial production and train installation crews. The night before he left, Pratt Dietrich found him in the barracks. You did it. You actually did it. We did it, Tony corrected. You backed me when you didn't have to. Yeah, well, don't let it go to your head. Dietrich handed him an envelope. This came for you, from Saipan. Tony's hands shook as he opened it. Michael's handwriting. Pop just heard the news. They're putting your cooling system on our birds. Whole crew wants to buy you a beer when this is over. We're naming our plane after you. Validor's luck. Figure if your duct can keep us from burning, that's good luck as we're ever gonna get. Love you, Pop. See you when we win this thing. Michael. Tony sat down on his bunk. He didn't cry. Couldn't cry. Just held the letter and let himself believe for the first time that his son might actually make it home. Dietrich cleared his throat. Kid's got good taste in names. Yeah. Morrison put you in for a commendation, and I heard LeMay personally call General Arnold to tell him about you. You might get a medal out of this. I don't want a medal. What do you want? Tony folded the letter carefully, put it back in the envelope. I want every pilot to come home. I want every aircraft to run cold. I want this war to be over so Michael can go back to being a college kid instead of a bombardier. He looked up at Dietrich. Think your engineers can give me that? No, but your duct's a start. In Wichita, Tony spent 6 weeks training mechanics on proper installation technique. He'd show them the angle, the positioning, the bolt torque specifications. Some of them listened. Some of them thought they knew better and tried to improve his design. Those installations always failed. You can't improve it, Tony would tell them. It's not elegant. It's not sophisticated. It's just right. Put it where I show you, and it works. Put it anywhere else, and it doesn't. By June, over 300 B-29s had been fitted with the Validor system. Failure rates dropped from 18% to less than 3%. The pilots stopped calling them flying coffins. They started calling them what they were supposed to be, superfortresses. On August 6, 1945, a B-29 named Enola Gay dropped an atomic bomb on Hiroshima. On August 9th, another B-29 Boxcar bombed Nagasaki. Both aircraft flew with Validor bypass cooling ducts installed. Both returned safely. The war ended 6 days later. Tony was back at Pratt when he heard. He was in Hangar 6 training a new batch of mechanics when someone ran in shouting that Japan had surrendered. The hangar erupted. Men were crying, laughing, hugging each other. Tony just stood there looking at Engine 3, the engine where this had all started. The burned engine that had killed 2 men and led him to build a duct out of scrap metal because he couldn't think of anything else to do. That night, he got a telegram from Michael. 3 words, "Coming home, Pop." 2 weeks later, Tony was discharged. He returned to Cleveland to his old job at municipal buildings, to fixing boilers and radiators and burst pipes. He never talked about the war, never mentioned the B-29. When people asked what he did in the service, he'd just say maintenance. But sometimes late at night, he'd think about Engine 3, about the temperature gauges dropping, about Morrison's face when the numbers held, about LeMay asking him if it would work, about Michael's letter Validor's luck. He'd saved his son. That was enough. The first letter came 3 weeks after Tony got back to Cleveland. He was under a sink in the municipal building basement frozen pipe, third one that week, when his supervisor found him. "Validor, there's a man upstairs asking for you. Says he's from the War Department." Tony's first thought was Michael. Something happened to Michael. He dropped his wrench and ran. The man waiting in the lobby wore a civilian suit, not a uniform. He was young, nervous, holding a briefcase like it might explode. "Mr. Validor, I'm Robert Marsh. We met at Wright Field. I was one of the Boeing engineers." Tony remembered, the kid from MIT who'd shaken his hand. "What's wrong?" "Nothing's wrong. Marsh opened his briefcase, pulled out a folder. "I'm compiling data on the Validor system for the official engineering report, and I thought you should see these." He handed Tony a stack of papers. Deployment statistics, installation records, flight logs. Tony scanned them. Numbers. Just numbers. Until his eyes caught on one line, operational aircraft equipped with Validor bypass cooling system 1-247, engine failure rate 2.3%, projected lives saved based on comparative failure analysis 1-842, 100 personnel. His hands started shaking. "That's conservative," Marsh said quietly. "We're not counting the missions that succeeded because the aircraft didn't abort due to engine failure. We're not counting the bombs that hit their targets. We're not counting the ground troops who didn't die because air support actually showed up." He paused. "Mr. Validor, you didn't just fix an engine, you changed the war." Tony sat down on the lobby bench. 1,800 lives. Minimum. That's what that piece of scrap aluminum had done. "The reason I'm here," Marsh continued, "is that Wright Aeronautical wants to patent the bypass cooling system. They're claiming it as an iterative improvement on their existing engine design. They're not mentioning your name." "I don't care about patents." "You should. Because if Wright gets the patent, they'll license it to commercial aviation after the war. They'll make millions, and you'll get nothing." Tony looked up. "I didn't do this for money." "I know, but you did it. Not Wright, not Boeing, not MIT, you." Marsh pulled out another document. "This is a patent application in your name. I've already filled it out. You just need to sign it." "Why do you care?" "Because I spent 3 years at MIT learning thermodynamics from men who couldn't solve this problem. And a plumber from Cleveland solved it in one night with a cutting torch and scrap metal." Marsh's voice was intense now. "That matters. That needs to be in the record. Otherwise, some Wright engineer who didn't do anything will take credit, and history will forget that the man who saved the B-29 program never finished 8th grade." Tony took the document, stared at it. "If I sign this, what happens? Wright will fight it. They'll say you were acting under military orders, that the design belongs to the government, that you don't have the technical expertise to understand your own invention. It'll be ugly." "Then why bother?" "Because it's the truth." Marsh met his eyes. "And because every pilot who came home because of your duck deserves to know who saved them." Tony signed. The fight lasted 8 months. Wright Aeronautical filed counterclaims. They brought in lawyers, expert witnesses, affidavits from their lead engineers. They argued that the bypass cooling concept was obvious to anyone skilled in the art, and that Tony had simply executed a design that was already in development. Morrison testified on Tony's behalf. So did Dietrich. So did the mechanics at Pratt who'd watched Tony build the prototype in the middle of the night. The patent examiner's ruling came down in February 1946. The Validor bypass cooling system represents a novel and non-obvious solution to a well-documented engineering problem. While the mechanical principles are straightforward, the application demonstrates innovative thinking. Patent granted to Antonio Validor with recognition of collaborative development by Wright Aeronautical and Boeing Aircraft. Tony got the patent. Wright got a licensing agreement. Boeing got manufacturing rights. Nobody got rich. But Tony's name was in the record. That same week he got a different kind of letter, from someone he'd never met. "Mr. Validor, you don't know me. My name is Catherine Morgan. My husband, Lieutenant Robert Morgan, flew B-29s out of Tinian from November 1944 until the war ended. He came home in September. When I asked him why he was still alive when so many of his friends weren't, he said, because a plumber fixed the engines. He told me about your cooling system. about how the planes stopped catching fire, about how crews stopped dying on the runway. I'm writing to say thank you. I have my husband back because of you. Our daughter will grow up with a father because of you. I don't know if anyone's told you this, but you're a hero to the families of every man who flew those missions. We'll never forget what you did. Tony kept that letter, put it in a box with Michael's letters from the war. He didn't show it to anyone, didn't talk about it, but sometimes late at night, he'd take it out and read it. 1,800 lives. That's what Marsh had said, minimum, but each of those lives had families, wives, children, parents. How many people did you actually save when you saved one pilot, 510? The number got too big to think about. Michael came home in October 1945. The train pulled into Cleveland at 3:47 p.m. on a Tuesday. Tony was waiting on the platform, heart-hammering, scanning every face in the crowd. Then he saw him. Thinner than he remembered. Older, but alive. They didn't hug. Men didn't do that in 1945. They shook hands. Michael's grip was strong. "Hey, Pop." "Hey, kid." They walked to Tony's truck in silence. Halfway there, Michael stopped. "I saw what you did. The whole squadron knew. They called your ducks Validor's lucky pipes. Guys would touch them before missions, like a good luck charm." Tony didn't know what to say to that. "We flew 32 missions," Michael continued. "Lost 4 aircraft. All 4 were mechanical failures unrelated to the engines. 0 engine fires, 0 overheating failures. You know what that means? You were safe." "We were safe because of you." Michael's voice cracked slightly. "Every time we came back, every time we landed and I could see you and Mom again, that was because you built something that worked. You saved my life, Pop. You saved all of us." Tony pulled his son into a hug then. To hell with what men were supposed to do. He held his boy and felt him breathing and thought about the temperature gauge dropping in Hangar 6, about Morrison's skeptical face, about LeMay asking if it would work. It had worked. Michael was home. That was all that mattered. But the letters kept coming. Not just from families, from pilots, navigators, engineers, men who'd flown combat missions and lived to tell about it. Some of them were simple "thank you." Some were detailed "third mission to Tokyo, January 45. Engine 3 hit 550 degrees on the climb out. Thought we were done, but the temperature held. Didn't spike, didn't catch fire. Completed the mission, made it home. Your duct saved us." One letter came from a pilot named James Harrell. Tony didn't recognize the name until he read the first line, "I was the pilot of the B-29 that burned at Pratt Army Airfield in March 1944. The one you saw burn. I lost my flight engineer and my radio operator that day. For a year after, I couldn't fly without thinking about them. Couldn't start an engine without waiting for the fire. But in June 45, I got reassigned to a new crew, new aircraft, with your cooling system installed. We flew 16 missions out of Guam. Never had an engine problem. Not once. I came home. I'm writing this from my living room in Michigan, watching my 2-year-old daughter play on the floor. I get to be her father because you fixed something that nobody else could fix. I don't know how to thank you for that, but I'm trying." Tony kept all the letters. Put them in the box with Catherine Morgan's letter and Michael's wartime correspondence. By 1947, there were over 40 letters. By 1950, nearly 100. He never answered them. Didn't know what to say. Your welcome for not letting you burn to death felt wrong. So he just kept them. And sometimes, when work was slow, or the pipes were frozen, or life felt small, he'd take them out and remember that once, for a brief moment, he'd done something that mattered. In 1948, the Air Force, newly independent from the Army, invited Tony to a ceremony at Wright-Patterson Air Force Base. They were retiring the last B-29s from active service, transitioning to the new B-50 and B-36 bombers. General Curtis LeMay, now commanding Strategic Air Command, would be speaking. Tony almost didn't go, but Michael convinced him. "You should see it, Pop. See what you built." They drove to Ohio together. The ceremony was outside on the tarmac with a dozen B-29s lined up in formation. Thousands of people attended. Veterans, engineers, politicians, reporters. LeMay's speech was short. He talked about the B-29's role in winning the war, the firebombing of Tokyo, the atomic missions, the strategic bombing campaign that brought Japan to its knees without a ground invasion. Then he said, "But none of that would have been possible without the men who kept these aircraft flying. The mechanics, the engineers, the technicians who solved problems that shouldn't have been solvable. I want to recognize one man in particular." Tony's stomach dropped. In April 1944, when the B-29 program was failing, when we were burning more planes on American runways than in combat, a maintenance mechanic at Pratt Army Airfield designed a cooling system that saved the entire program. "Antonio Validor, would you please stand?" Michael elbowed him. "That's you, Pop." Tony stood slowly. Every face in the crowd turned toward him. "Mr. Validor's innovation," LeMay continued, "reduced engine failure rates by 83%. Over the course of the war, aircraft equipped with the Validor bypass cooling system flew 31,482 combat missions. Those missions delivered 147,000 tons of ordnance. They helped end the war 8 months earlier than projected, and they brought 9,200 aircrew members home alive. 9,200. Tony had thought it was 1,800. Marsh had said 1,800. But that was just direct engine failures prevented. LeMay was counting every crewman on every mission that succeeded because the engines didn't fail. 9,200 lives. "Mr. Validor," LeMay said, looking directly at him, "on behalf of the United States Air Force and every man who flew these aircraft, thank you." The crowd erupted in applause. Tony stood there frozen, trying to comprehend the number. 9,000. That was a small town. That was a college. That was too many people to visualize. He sat down. The ceremony continued, but he couldn't hear it anymore. Just sat there staring at the B-29s on the tarmac, thinking about all the missions those planes had flown, all the men who'd come home, all the families who'd stayed intact because a piece of aluminum tube had forced air to flow where it didn't want to go naturally. After the ceremony, people came up to him, shook his hand, thanked him. Some were crying. One old man had to be 70, grabbed Tony's arm and said, "My grandson flew with the 500th. 30 missions, never had engine trouble. He's a teacher now, has 2 kids. That's because of you." Tony nodded, didn't trust himself to speak. On the drive back to Cleveland, Michael said, "You okay?" "I don't know." "That's a lot of people, Pop." "Yeah." "Does it feel real?" Tony watched the Ohio countryside roll by. Trees, farms, towns, people living their lives not knowing that a plumber once built something in the middle of the night that let 9,000 men come home to places just like this. "No," he said finally. "It doesn't feel real." "Does it feel good?" Tony thought about that, about the letters in the box, about Catherine Morgan's daughter who'd grown up with a father, about Michael sitting next to him alive and healthy and whole. "It feels heavy," he said. "Knowing that many people lived or died based on something I did, that's heavy." "You saved them, Pop." "I built a pipe. That's all I did. Built a pipe and got lucky that it worked." Michael shook his head. "You saw something nobody else saw. You took a risk nobody else would take, and you were right. That's not luck. That's genius." "I'm not a genius. I'm a plumber." "You're both." Michael smiled. "You're a genius plumber, and 9,000 people are alive because of it." Tony let that sit for a while. Then he said, "You know what's weird? I still fix the same pipes I fixed before the war. Same building, same leaks, same frozen radiators, like nothing changed. Everything changed. Not for me. I go to work. I fix things. I come home. That's the same. But you know what you did. You know what you're capable of. That changes things." Tony wasn't sure about that, but he didn't argue. That night he added LeMay's speech to the box. 9,200. He wrote the number on the envelope just so he wouldn't forget. Not that he could forget. That number would be with him forever. In the years after, Tony lived quietly. He fixed pipes. He went to church. He watched Michael get married, have kids of his own. He never talked about the war unless someone asked directly. And even then, he kept it brief. But sometimes, late at night, he'd think about Engine 3, about the temperature gauge dropping, about Morrison's face, about LeMay's question, "Will this work?" He'd said yes, and he'd been right. 9,200 people were walking around living their lives because he'd been right. That was heavy. Michael was right about that. It was the heaviest thing Tony would ever carry, but it was also the most important thing he'd ever do. And deep down in a place he rarely examined, Tony knew that if he had to go back and do it again, if he had to stand in front of that burned engine at 3 a.m. with scrap metal and a cutting torch, betting his career and possibly his freedom on an idea that made no sense to anyone but him, he'd do it exactly the same way. Because when something's broken, you fix it. That's the job. That's always been the job. Tony had fixed something, and 9,200 people had lived because of it. That would have to be enough. But it wasn't enough for everyone. In 1952, Tony got a letter from Wright Aeronautical. They were developing a new engine, the R3350 turbo compound for commercial aircraft. They wanted to license his bypass cooling patent. They offered him $15,000. Tony showed the letter to Michael, who was working as an engineer at General Electric by then. "That's not enough," Michael said immediately. "Pop, your design is going into every commercial airliner they build. That's worth 10 times this." It's just a pipe. It's the pipe that makes the whole thing work. Michael grabbed a pencil, started calculating. If they're putting your system on the Lockheed Constellation, the Douglas DC-7, the Boeing Stratocruiser, and they are, because those all use Wright engines, you're talking about licensing fees that should be at least $100,000, maybe more. Tony stared at the number. $100,000. He'd made $200 a year his entire life. That's too much. It's what you're owed. I didn't do it for money. I know, but Wright's going to make millions off your design. They should pay you fairly for it. Tony signed the $15,000 agreement. Michael was furious. Pop, why? Because I don't need $100,000. And because if I fight them, it'll take years and I'll spend the whole time thinking about money instead of doing my job. Tony folded the check. This is more money than I've ever seen. It's enough. It's not about enough. It's about what's right. Tony looked at his son. You know what's right. 9,000 men came home because I built something that worked. That's right. The money doesn't matter. But Michael was wrong about one thing. Wright didn't make millions off the Validor system. They made tens of millions. By 1955, every commercial aircraft using Wright R-3350 engines, and that was most of them, had bypass cooling ducts based on Tony's design. Lockheed Constellations, Douglas DC-7s, Boeing Stratocruisers. The system became so standard that most passengers never knew it existed. They just flew safely, never knowing that a plumber from Cleveland had made their flight possible. Tony never flew commercial, didn't see the point. But in 1958, Michael took him to Cleveland Hopkins Airport. I want to show you something. They stood on the observation deck. Below a WWII Constellation was taxiing for takeoff. Michael pointed at the engines. You see those cowlings, the way they're shaped? That's modified to accommodate your duct system. Every single one of those engines has your design inside it. That plane's going to Los Angeles. 300 passengers. None of them know your name, but they're all flying safely because of you. Tony watched the plane take off. Watched it climb into the gray Ohio sky. Thought about the B-29s over the Pacific, about Michael's letters, about Catherine Morgan's husband coming home. Does it bother you? Michael asked. That nobody knows? No. It bothers me. Why the planes work? That's all that matters. Michael shook his head. You're impossible, Pop. But that wasn't quite true. Tony did care about one thing, making sure the young mechanics understood why the system worked. Because if they didn't understand it, they'd try to improve it. And every time someone tried to improve it, they made it worse. In 1960, a Boeing engineer named Harold Schmidt contacted Tony. They were having problems with the new 707 jet engines overheating in the rear compressor stages. Different technology than the B-29, but the same basic problem. Air not flowing where it needed to flow. I read your patent, Schmidt said over the phone. The principle is elegant. Force the flow to go where it's needed instead of where it wants to go. I think we can apply the same concept to turbine cooling. You want me to design something for a jet engine? I want you to consult. Come to Seattle for a week. Look at our cooling problems. Tell us what you see. Tony was 64 years old. He'd been fixing pipes for 40 years. He'd never seen a jet engine up close. I don't know anything about jets, he said. You didn't know anything about radial engines either. That didn't stop you from fixing them. Tony flew to Seattle his second time on an airplane, first time on a jet. The Boeing plant was massive. Hundreds of workers, dozens of aircraft in various stages of assembly. They took him to the engine testing facility, showed him the 707's Pratt & Whitney JT3C turbojets. The problem was in the turbine section. The rear stages were running hot, not catastrophically, but enough to reduce engine life and increase maintenance costs. Boeing's engineers had tried modifying the air passages, adjusting the cooling vents, redesigning the blade configurations. Nothing worked. Tony spent 2 days just looking at the engine, watching the airflow patterns on paper, studying the temperature data, asking questions that the engineers thought were too simple. On the third day, he said, "You're cooling from the outside in. You need to cool from the inside out." The lead engineer, a man named Patterson, MIT graduate, 20 years at Boeing, frowned. That doesn't make sense. The hottest point is the combustion chamber. You can't route cooling air through the center without compromising combustion efficiency. You're not routing it through the center, you're routing it around the center through the turbine shaft. Hollow out the shaft, create a cooling passage, force air through it under pressure. The air comes out at the rear turbine stages exactly where you need it coolest. Patterson stared at him. We can't hollow out the turbine shaft. It's a load-bearing component. The structural integrity. Then make it thicker. Use stronger materials. The cooling efficiency will more than compensate for the added weight. You're talking about a complete redesign of the turbine shaft assembly. I'm talking about putting air where it needs to be. Tony looked at Patterson. You've been trying to solve this from the outside because that's where all your cooling systems are. But the problem's on the inside, so put the solution on the inside. Boeing spent 8 months developing what they called the internal cooling passage system. It worked exactly as Tony predicted. Turbine temperatures dropped by 75 degrees. Engine life increased by 40%. Reached by 40%. Maintenance intervals doubled. They offered him a consulting contract, $500 per day plus expenses. He turned it down. Why? Schmidt asked. You just saved us millions in warranty costs. We want to keep you on retainer for future projects. Because I'm a plumber in Cleveland. That's my job. This was just helping out. You could make a fortune as an aerospace consultant. Tony thought about the $15,000 from Wright Aeronautical, about the 9,200 lives, about Michael's letter from Saipan. I don't need a fortune, he said. I need to fix the boiler at City Hall before winter. That's what I do. He flew back to Cleveland, went back to work, never told anyone at municipal buildings where he'd been, but the calls kept coming. Lockheed had a cooling problem with the C-130 cargo aircraft. Could he take a look? Douglas was struggling with engine overheating on the DC-8. Would he consult Pratt? And Whitney was designing a new turbofan engine. Could he review the cooling system design? Tony said no to all of them. He was 65, then 67, then 70. He was tired. His hands hurt from 45 years of wrench work. He just wanted to fix pipes and go home to his wife and maybe see his grandkids on weekends. But in 1972, he got a call he couldn't refuse. Mr. Validor, this is Dr. James Fletcher. I'm the administrator of NASA. Tony almost hung up, thinking it was a prank. We're developing a new spacecraft cooling system for the space shuttle program. We're having some challenges with thermal management in the engine compartment. Your name keeps coming up in our engineering reviews. Would you be willing to visit Houston and look at our designs? I'm 76 years old. Yes, sir, but you're also the man who solved the B-29 cooling crisis with a piece of scrap metal. We need that kind of thinking. Tony went to Houston. They showed him the space shuttle main engine, the most powerful rocket engine ever built. The cooling problems were catastrophic. The engines ran at temperatures that would vaporize steel. The hydrogen fuel served as a coolant, but the flow patterns weren't optimal. Hotspots developed. Engines failed during testing. Tony looked at the designs for 3 days. Then he asked, why are you cooling in sequence hot to cold stage by stage? The lead engineer, a woman named Sarah Chen, PhD from Caltech, said, because that's how the fuel flows through the system. It enters here, absorbs heat as it moves through the cooling channels, then enters the combustion chamber. But the hottest point is the combustion chamber throat. By the time your coolant gets there, it's already absorbed too much heat. It's not cold anymore. We can't change the fuel flow direction. The pumps are designed at a bypass. Tony pointed at the schematic. Take some of the cold fuel before it enters the system. Route it directly to the throat cooling channels. It'll be coldest right where you need it coldest. That would require a separate pump, additional plumbing, more weight. Less weight than a failed engine. NASA spent 18 months implementing what they called the Validor bypass cooling concept in the Space Shuttle main engine. It reduced throat temperatures by 200 degrees. Engine reliability increased by 35%. The shuttle flew for 30 years with those engines. Tony watched the first shuttle launch on television in 1981, Columbia, lifting off from Kennedy Space Center. 2 solid rocket boosters and 3 main engines pushing it into orbit. His wife Mary sat beside him. Those are your engines, she said. They're NASA's engines. I just gave them an idea. You always just give them ideas, and the ideas always work. Tony watched the shuttle disappear into the sky, thought about B-29s over Tokyo, about Michael's letter, about 9,200 lives. Now his cooling system was going to space. He started laughing, couldn't help it. Mary looked at him like he'd lost his mind. What's funny? I dropped out of school in 7th grade. I spent my whole life fixing frozen pipes in basements, and now my work is in a spacecraft. You're an engineer, Tony. I'm a plumber. You're both. He'd heard that before. From Michael, from Marsh, from Schmidt at Boeing. They all wanted him to be something bigger than what he was. But Tony knew the truth. He was a plumber who'd gotten lucky, who'd seen a problem at the right time and had the right background to recognize it. That was all. The fact that his solution had saved thousands of lives changed an industry and eventually made it to space that was just how things worked sometimes. You fix a leak in the right place and the whole system starts working. In 1978, the American Society of Mechanical Engineers gave Tony their Medal of Achievement. Michael convinced him to go to the ceremony in New York. Tony wore a borrowed suit that didn't fit right and stood on stage while someone read his biography. Antonio Validor, born 1896 Cleveland, Ohio, 7 years of formal education, 48 years as a maintenance mechanic, inventor of the bypass cooling system that saved the B-29 program, influenced commercial aviation design, and contributed to spacecraft thermal management. His work has touched 3 generations of aerospace engineering. They gave him a medal, people applauded, someone wanted to take his picture. In the lobby afterward, an old man approached him, thin, gray, walking with a cane. "Mr. Validor, I'm James Harrell. I wrote you a letter in 1946. Tony remembered. The pilot whose plane had burned at Pratt, who'd lost his crew, who'd come back and flown 16 missions with Tony's cooling system. "I remember. I wanted to shake your hand. I've been wanting to do that for 32 years. Harrell held out his hand. It was shaking slightly. "You gave me my life back. You gave me my daughter. She's 33 now, has 2 kids of her own. I got to walk her down the aisle. I got to meet my grandchildren. None of that happens if you don't fix that engine in 1944. Tony shook his hand. "You did the flying. You took the risks. I flew. You kept me alive while I did it." Harrell smiled. "There's a reunion next month. B-29 crews from the 20th Air Force. About 40 of us left. You should come." "I don't know if... Please, these men want to meet you. They want to say thank you." Tony went to the reunion. It was in a VFW hall outside of Dayton. 40 men, most in their 70s and 80s. Some in wheelchairs. Some walking with canes. All of them alive. When Tony walked in, someone recognized him. Word spread. The talking stopped. Then one man started clapping. Then another. Then all of them. Tony stood there frozen while 40 men who'd flown combat missions over Japan gave him a standing ovation. Some were crying. One man had to be 85 saluted him. Harrell stepped forward. "Gentlemen, this is Antonio Validor, the man who kept us flying." For the next 3 hours, they told him their stories. Missions they'd flown. Close calls they'd survived. Engines that had stayed cool when they should have burned. One pilot said, July 1945, mission to Osaka, lost an engine to flak over the target. Engine 2 caught fire. We shut it down, activated the suppression system, but engine 3 started running hot, hit 510 degrees. We thought we were done, but the temperature held, didn't spike, didn't catch fire. We made it back to Tinian on 3 engines. That was your duct. That was you keeping us alive. Another said, I flew 31 missions, not one engine fire, not one overheating failure. You know what the odds of that were before your system almost zero, after your system normal. You made survival normal. Tony listened to all of them, every story, every close call, every mission that succeeded because the engines didn't fail. When it was over, when the last story had been told, Harrell walked him to his car. You don't talk much, do you? Harrell said. Not much to say. These men, we've been trying to find you for years, to thank you properly. Most people don't know your name. The history books talk about the B-29, about LeMay, about the atomic missions, but they don't mention the plumber who made it all possible. That's fine. It's not fine. It's not right. Tony looked at Harrell. You want to know what's right? All of you are alive. You're standing here telling me your stories, showing me pictures of your grandkids. That's right. That's all I needed. Harrell's eyes filled with tears. Thank you, Mr. Validor. Tony? Call me Tony. Thank you, Tony, for giving us our lives back. Tony drove home that night thinking about the 40 men in that VFW hall. 40 out of 9,200. Just a fraction. But each one with stories, families, decades of life that wouldn't have happened without a piece of aluminum tubing forcing air to flow against its nature. He wondered about the other 9,160. Where they were. What they were doing. How many grandchildren they had collectively. How much life his simple fix had created. The number was too big to comprehend. It always had been. Mary was waiting when he got home. How was it while heavy? She knew what that meant. He'd used that word before, after LeMay's speech, after the patent fight, after the NASA consultation. Heavy. The weight of knowing that your actions had consequences so large you couldn't see all the edges. You saved them, she said. I built a pipe. Same thing. No, building a pipe is easy. Saving 9,000 people, that's too big. I didn't set out to save anyone. I just wanted to fix an engine so my son wouldn't burn. But you did save them, whether you meant to or not. Tony sat down, looked at his hands. 72 years old, scarred from decades of work. Shaking slightly now, arthritis, the doctor said. These hands had built the duct, had cut the aluminum, had bolted it in place, had started the engine and watched the temperature drop. Simple work. Manual labor. Nothing complicated. But somehow that simple work had rippled out across the world, across decades. It's touching thousands of lives he'd never meet. You know what I think about, Tony said quietly. I think about the men who didn't make it, the ones who burned before I built the duct. The pilots who died at Pratt at the other training fields. I was too late for them. You couldn't have known? I know, but I still think about them. 17 B-29s burned before mine worked. How many men was that, 80-90? And 9,000 lived because you succeeded. Doesn't make the 90 matter less. Mary put her hand on his. No, but it makes the 9,000 matter more. Tony Validor died on February 14, 1982. He was 86 years old. Heart failure, the doctor said. Quick, peaceful. He went to sleep and didn't wake up. The obituary in the Cleveland Plain Dealer was 4 sentences long. Antonio Validor, 86, retired maintenance mechanic for Cleveland municipal buildings. Served in the Army Air Forces during World War II. Survived by his wife, Mary's son Michael, 4 grandchildren. Services at St. Stanislaus Church, Saturday at 10 a.m. No mention of the B-29. No mention of the cooling system. No mention of 9,200 lives. Michael called the newspaper. You need to run a correction. My father invented the bypass cooling system that saved the B-29 program. He has a patent. He was recognized by the Air Force. This obituary makes him sound like he fixed toilets. The editor was polite but firm. We print what the family provides. If you'd like to submit additional information for a follow-up piece, we can consider it. Michael wrote a 3-page letter detailing everything. The burning B-29s, the midnight experiment, the patent fight, LeMay's speech, the NASA consultation. He included documentation, photographs, letters from pilots. The newspaper never published it. At the funeral, 47 people attended. Family, neighbors, a few co-workers from municipal buildings, and 3 old men Michael didn't recognize. After the service, one of them approached. He had to be 90 years old, walking with the cane medals on his jacket. You're Michael Validor. Yes. Your father saved my life in 1945. I flew B-29s out of Tinian. I just wanted to pay my respects. Michael shook his hand. Thank you for coming. The old man looked at Tony's casket. Does his obituary mention what he did? No. That's a crime. That's a goddamn crime. The man's voice shook. There should be thousands of people here. Every pilot who flew a B-29. Every family member of those pilots. Every person alive today because their grandfather didn't burn to death in an engine fire. Your father should have a state funeral. He should have a monument. He wouldn't have wanted that. I know, but he deserved it. The 3 old pilots stood at Tony's grave for 20 minutes after everyone else left. Michael watched them from a distance. They weren't crying, just standing there, remembering. When they finally walked away, one of them stopped beside Michael. We've been trying to get your father recognized properly for years. The Air Force Museum at Wright-Patterson has nothing about him. The Smithsonian doesn't mention him. The history books credit Boeing engineers who worked off his design. It's not right. He didn't care about recognition. We know. That's why it matters more. The pilot handed Michael a business card. We're part of the B-29 Veterans Association. About 200 of us left now. We want to do something. A memorial. A plaque. Something so people remember what he did. Michael looked at the card. What did you have in mind? 6 months later, a small bronze plaque was installed at the National Museum of the United States Air Force at Wright-Patterson. It was placed next to a B-29 Superfortress on display, one of only a few surviving aircraft from the war. The plaque read, in memory of Antonio Validor, 1896 to 1982, who developed the bypass cooling system that solved the B-29 engine overheating crisis of 1944. His innovation reduced engine failure rates by 83% and enabled the successful strategic bombing campaign against Japan. An estimated 9,200 aircrew members survived the war due to his contribution. Validor, a maintenance mechanic with 7 years of formal education, represents the countless unsung heroes whose ingenuity and dedication helped achieve victory. Michael stood in front of that plaque in October 1982 and cried for the first time since his father died. A museum visitor, middle-aged woman walking with 2 teenagers, stopped beside him. Are you okay? Michael pointed at the plaque. "That's my father." The woman read it. Her eyes widened. "Your father invented this, yeah. I didn't know. I've been to this museum 5 times. I've walked past this B-29 dozens of times. I never read the plaque." That was the problem. Nobody read the plaque. Nobody knew the story. Tony Validor had changed aviation history, had saved thousands of lives, had contributed to spacecraft design, and the world had forgotten. But Michael couldn't let that happen. Not completely. He spent the next 3 years collecting everything. Every letter his father had received from pilots and families. Every technical document from the patent files. Every photograph from Wright Field and Pratt Army Airfield. Every piece of correspondence with Boeing, Lockheed, NASA. He assembled it all into what he called the Validor Archive. 3 boxes of materials documenting his father's work. He donated it to the Air Force Historical Research Agency at Maxwell Air Force Base in Alabama. The archivist who received it, a woman named Dr. Patricia Henderson, spent 2 weeks reviewing the contents. Then she called Michael. "This is extraordinary. I had no idea this existed." Most people don't. Your father's contribution has been systematically overlooked in the historical record. The standard texts on the B-29 program don't mention him. The engineering journals credit Wright Aeronautical corporate research teams. Even Curtis LeMay's autobiography doesn't include his name. Can you fix that? I can make sure researchers have access to the truth. What they do with it is up to them. Over the next decade, a few academic papers mentioned Tony Validor. A doctoral dissertation on B-29 engineering challenges included a chapter on the cooling crisis. A book about unsung heroes of World War II devoted 3 pages to him. But he remained largely forgotten. In 1995, Michael was contacted by a documentary filmmaker named Sarah Chen, the same Sarah Chen who'd worked with Tony at NASA 20 years earlier. She was producing a film about the B-29 program for the History Channel. "I want to tell your father's story," she said. "The whole story, not just a footnote, a full segment, maybe 10 minutes of the documentary." "Why now?" "Because I've spent my entire career working on aerospace cooling systems. Every technique I use traces back to your father's basic principle, and I just realized that most people in my field have never heard of him. That's wrong." The documentary aired in March 1996. Tony's segment was actually 12 minutes. It included interviews with surviving pilots, footage of B-29's technical diagrams of the cooling system, and Michael talking about his father. The final shot was the bronze plaque at Wright-Patterson. After it aired, Michael received 237 letters, some from veterans who'd flown B-29s, some from their children or grandchildren, some from people who'd never heard of Tony Validor but were moved by the story of an ordinary man solving an impossible problem. One letter came from a high school student in Oklahoma. "Dear Mr. Validor, I watched the documentary about your father for a history class assignment. My teacher said we had to write about an unsung hero from World War II. I picked your dad because nobody in my class had heard of him. I think it's unfair that people like Einstein and Oppenheimer are famous, but your dad isn't. He saved more people than most generals. I think there should be a holiday for people like him. Thank you for sharing his story. Jessica Thornton, age 16. Michael kept that letter. Put it in the box with all the other letters his father had saved. The box was getting full. In 2004, Michael was invited to speak at MIT's School of Engineering. They were hosting a symposium on elegant solutions in aerospace design. His father's bypass cooling system was being used as a case study. Michael stood in front of 200 engineering students and faculty and told them about Tony, about the frozen pipes in Cleveland, about Engine 3 burning at Pratt, about the midnight experiment with scrap metal. When he finished, a professor raised his hand. "Your father's solution is taught in every undergraduate fluid dynamics course now. We call it forced convective bypass, but I never knew there was a real person behind it. I thought it was just engineering." "It was engineering," Michael said. "But it was also a man who couldn't stand watching people die. That's the part nobody teaches." After the lecture, a young woman approached him, Indian, maybe 22, carrying a stack of textbooks. "Mr. Validor, I'm Priya Sharma. I'm writing my master's thesis on thermal management in high-performance engines. Your father's patent is cited in every paper I've read, but none of them tell the story. They just reference the technical specifications." That's how engineering works. The solution matters more than the person. But shouldn't we remember both? Priya's eyes were intense. Shouldn't we know that the forced convective bypass principle came from a man who fixed boilers that changes how I think about problem solving? It means I don't need to know everything. I just need to see clearly. Michael smiled. That's exactly what my father would have said. Priya's thesis, completed in 2006, included a historical section titled The Human Context of Technical Innovation. It detailed Tony's background, his wartime service, and his post-war influence on aerospace design. The thesis won MIT's award for Best Graduate Research in Mechanical Engineering that year. In her acknowledgments, Priya wrote, "To Antonio Validor, who taught us that the most sophisticated solutions often come from the simplest observations." The thesis was published in the Journal of Aerospace Engineering. It was the first peer-reviewed academic paper to give Tony Validor primary credit for the bypass cooling innovation. Michael was 79 years old when he read it. He sent Priya a letter, "Thank you for remembering my father the right way. He would have been proud to know that someone from the next generation understood what he did." But Michael's health was failing. Emphysema, lung cancer. The doctors said it was from years of exposure to aviation fuel and hydraulic fluid, occupational hazard of being an aircraft engineer. In 2008, Michael was hospitalized. He knew he was dying. He called his daughter Rebecca to his bedside. "The archive," he said, his breathing labored. "Your grandfather's archive. It's in the garage. 3 boxes. Don't let them get thrown away." "I won't, Dad." "Promise me something else. Keep telling his story. Don't let him disappear." "I promise." Michael died 2 weeks later. Rebecca kept her promise. She scanned every document in the archive, uploaded them to a website she created, the validorproject.org. She included Tony's biography, the patent documents, letters from pilots, photographs, and links to academic papers that mentioned him. The website got 43 visitors in its first month, mostly family members, a few aviation enthusiasts. Then in 2012, a high school history teacher in Texas found it. He assigned his students to research unsung heroes of World War II using primary sources. Half the class picked Tony Validor. One of those students posted about it on Reddit. The post went viral. Within a week, the validorproject.org had 250,000 visitors. Comments poured in. "My grandfather flew B-29s. He told me about the cooling system but never mentioned who invented it. This is incredible. I'm an aerospace engineer and I learned about forced convective bypass in school, but nobody told me it was invented by a plumber. This changes everything I thought I knew about innovation." We need more stories like this. The people who actually fix things are always forgotten. Rebecca watched the website traffic surge and thought about her grandfather, the quiet man she'd barely known, who'd fixed her bicycle when she was 7, who'd taught her that if something was broken, you looked at it until you understood why, and then you fixed it. She'd never known he'd changed history. He'd never told her. In 2015, Boeing announced they were establishing the Antonio Validor Innovation Award, an annual prize for engineers who solved complex problems with elegant, simple solutions. The first recipient was a young engineer who designed a new turbine cooling system for the 787 Dreamliner. In his acceptance speech, he said, "Antonio Validor proved that you don't need to be the smartest person in the room. You just need to see what everyone else missed. That's the standard I'm trying to live up to." Rebecca attended the ceremony. Afterward, the Boeing CEO approached her. "Your grandfather's work is still influencing our design 70 years later. Every commercial aircraft we build uses variations of his bypass cooling principle. That's a legacy." He would have said he just fixed a leak. The CEO smiled. "The best engineers always do." But the real testament to Tony's legacy wasn't in Boeing boardrooms or MIT symposiums. It was in the quiet ways his work rippled through the world. In 2018, a NASA engineer working on the Mars Perseverance rover used a modified bypass cooling system to manage heat from the rover's electronics. The principle was the same force the coolest air to the hottest components. In 2020, a team at Johns Hopkins developed a new cooling system for MRI machines based on Validor's forced convective bypass method. It reduced operational costs by 40%, 40%, and made the machines feasible for smaller hospitals. In 2023, a Tesla engineer designed a battery cooling system using bypass airflow to prevent thermal runaway in electric vehicle batteries. The patent cited Validor's 1946 patent as prior art. Tony Validor never knew about any of this. He died in 1982 thinking his contribution had been forgotten. But his work lived on, adapting, evolving, solving new problems in contexts he never could have imagined. Rebecca is 73 now. She maintains the website. She answers emails from students and engineers and historians who want to know more about her grandfather. She gives talks at schools and engineering conferences. Her favorite story to tell is about the box of letters. The one Tony kept. The one with Catherine Morgan's letter about her husband coming home. The one with Michael's letter from Saipan. The The one with all the thank you notes from pilots and families. My grandfather saved those letters his entire life, Rebecca tells audiences. Not because he was proud he never talked about what he did, but because those letters reminded him why it mattered. Every name in those letters was a person who got to live. That's what engineering really is. It's not about the technical specifications or the patents or the awards. It's about people living instead of dying. She always ends with the same message. My grandfather was a plumber from Cleveland who barely finished 7th grade. He changed aviation history because he looked at a problem everyone else thought was impossible and saw a simple solution. He taught us that expertise isn't about credentials. It's about seeing clearly and having the courage to act on what you see. That's a lesson that matters in every generation. The bronze plaque at Wright-Patterson Air Force Base is still there. Most visitors still walk past it without reading it. But some stop. Some read Tony's name and wonder who he was. Some look it up on their phones and find the validorproject.org and learn the whole story. And every year on the anniversary of Tony's death, a few old men, fewer each year, visit that plaque. They're the last of the B-29 pilots, the ones who flew with Validor's lucky pipes. They stand there in silence, remembering the engines that didn't burn the missions. They completed the homes they returned to. They're remembering the plumber who saved their lives. In 2024, there are only 3 of them left. They're all over 100 years old now. They probably won't make it to next year's memorial, but their children come, and their grandchildren, and their great-grandchildren. Hundreds of people who exist because Tony Validor built a pipe in the middle of the night and bet his career that it would work. They don't all know his name, but they're alive because of him. That's the legacy, not the patents or the plaques or the awards, not the academic papers or the engineering textbooks or the Boeing Innovation Prize. The legacy is life. 9,200 men who came home, their children, their grandchildren, their great-grandchildren. Tens of thousands of people walking around today living their lives never knowing that a plumber from Cleveland is the reason they exist. Tony would have said that was enough. He would have been right. Because in the end, the most important things aren't remembered with monuments or awards. They're remembered in the quiet continuation of life. In families that exist because someone came home. In children who grew up with fathers because an engine didn't catch fire. In the simple, immeasurable gift of tomorrow. Tony Validor fixed a pipe. And in doing so, he gave thousands of people their tomorrows. That's not just engineering. That's love. If you believe his name should be remembered, share this story. Write his name in the comments below. Tell someone about the plumber who changed history. Because the greatest heroes are often the ones nobody knows until someone takes the time to remember. Antonio Validor, 1896 to 1982. Plumber, mechanic, inventor, hero. He built it with humble hands, but it's remembered with grateful hearts.